So we're going to look at finding a linear equation given certain information, and in particular given 2 points, so we can come up with the equation for a straight line or a linear equation given 2 points. Let's see how that's done. Firstly, you just need to remember a few things from your previous work. Horizontal lines have the equation y equals c, where c is the y-intercept. So for example, if you've got the equation y equals 5, it'll always have a y value of 5. So if you have a xy plane and this is point 5 up here on the y-intercept, it will be a horizontal line. Okay, another way of looking at where's the mx, the m is 0, so it's 0x, so that'll be 0 and you'll just have the y-intercept only. Vertical lines are x equals k, where k is the x-intercept. So vertical line, let's say we've got the line x equals -3, it'll be a vertical line that always has the x value of 3, and it's a vertical line. Just that should be something you know already. Okay, and we're going to use y equals mx plus c in this, and to find the equation of a line given any 2 points, find the gradient. And then there's two ways of doing it. I'm going to show you both of these ways, using y equals mx plus c and then using what's called the point gradient form. Okay, so please make sure you know that's called the point gradient form. Take that down, that's very important. Point gradient form of a straight line or a linear function. You might have seen that last year previously. Okay, so y minus y1 equals mx minus x1. x1 y1 is just a point on the line. Okay, so that one, the 1 after the x and the 1 after the y is just the name. That refers to the x and the y values of 0.1, and the little 2's mean the x and the y values of 0.2. Okay, this is given 2 points, and that's also what these little 1's and 2's mean here. That's from 0.1. Okay, it's important. So y minus y1 equals m times x minus x1. For those two methods to make sense, I'm going to show you an example, and it says find the equation of the straight line shown. Well, what information do we have? We have 2 points, and we need to name them point 1 and point 2. I'm going to call this one point 1. It doesn't matter which one's which. Okay, point 1 is a y-intercept, so point 1 is going to be x1 y1. So that's a comma, and that's equivalent to 0 1. You can see that from the graph. x2 y2, we can see up here 4 13. Okay, there's two methods, and the first method involves finding the gradient. The gradient is a rise over the run, or it's y2 minus y1 over x2 minus x1. Can you see that that's simply just rise over run, especially from your work last year? So the y2 is 13, the y1 is 1, and the x2 is 4, the x1 is 0. So we've got 12 over 4, which is 3. Okay, so we've got a gradient, and then we can use, method 1 can be using that point gradient form. So y minus y1 equals m x minus x1. It just means that you use the m, the gradient, and one of the points given. Doesn't actually have to be x1 y1. It can just be any of the points given. I'm going to just show that it works by using this one. Okay, so it doesn't literally have to be the first point, it just needs to be a point on the line, and x2 y2 is on the line. Alright, so y minus, well, the y is 13, m is 3, the x value is 4, and we've got expanding the right hand side, 3 by x is 3x minus 3 by 4 is 12, y minus 13 equals 3x plus 12. I'm going to add 13 to both sides, y equals 3x plus 1, and there's our equation to the line. Method 2 is y equals mx plus c is the other way. Well, in this case we've got some given information there. We know that we've already worked out the gradient is 3 from previous steps, so we're going to borrow that information. 3x plus c, well, we've got c given to us, that's 1, the y-intercept, it's right there. So y equals 3x plus 1. So we get that either way. Here we have another example. So find the equation of the straight line shown, and again we're given information and we're given 2 points. So here's a method. So again we could go gradient is y, now we could call that point 1. It doesn't matter how you name your points, okay, just be consistent. So this could be point 1 at the top and point 2 at the bottom. So the gradient is rise over run. That's the rise and that's the run, and we need to know, okay, what have we got here? So x1 x1 y1, that equals, doesn't matter which way you name them, so I'm going to call that 3, 11 is my x1 y1, x2 y2 is equivalent to 6, 7, as long as you're consistent. So we've got y2 over minus y1 on the top, so that's 7 minus 11, and x2, which is 6, and x1, which is 3, negative 4 on 3. So the gradient is negative 4/3. That makes sense because you can see that it's a falling line, and one option you have is the point gradient form of a straight line. So it means you need a point and you need the gradient, which we do have. Okay, so we've got basically, I'll move down onto the next line there, y minus y1. Now I said y1 was 7, so y minus 7, and I could have used the other point, by the way, and we've got the gradient from the previous step, negative 4/3, x minus the, I said so as long as you use the same point, so I've used the y from point 2, even though it's, the formula says 1, as long as you use the same point, so I need to use the x value from that same point. Okay, it doesn't have to be y1 x1 as long as it's the same point. Okay, so we've got that there, and we've got y minus 7 equals negative, now we've got to use a distributive rule, negative 4/3 x minus negative 4/3 times 6. Now 6 is 6 on 1, students, as you know. Y minus 7 equals 4/3 x. Okay, we've got negative 4 by 6 is negative 24 divided by 3 by 1, which is 3. We've got y minus 7 equals negative 4/3 x. Okay, 24 over 3 is 8, so that's negative 8 minus negative 8. See that? Minus negative 8. it's plus 8. And then we've got the next line, y minus 7 equals negative 4/3. Let me just back up there, sorry, jump the gun a little bit. So we've got, now what I want to do is get the 7 on the right hand side, so I need to undo the negative by adding 7. Got to add 7 to this side, so that'll be 15. 8 and 7 is 15. So we've got y equals negative 4/3 x plus 15. Now there was another way of doing this. The second method involves going back to this step here where you found the gradient and then writing, this is a second method, alright? So you've still got to do that first step the same, and then write down y equals mx, mx, that's horrible, mx plus c. Alright, apologies, that came out a bit untidy. And then we've got m as the gradient, negative 4/3. We've got now what are we going to do here? We've got a y and an x. It just means you need to use one of the 2 points on the line, as long as it's on the line. Okay, now last time I used that one, so look, just to show you, I'm going to use that one this time, as long as it's on the line. It's all that matters. So for the x, I'm going to use this x, this x. You can use either of them. Instead of x, I'm putting in 3, and then for the y, I put in the y value. Again, you could have used this point instead. So we've got 11. So 11 equals negative 4/3 times 3 plus c. Negative 4/3 times 3 is negative 4 plus c, and we've got 11 on the left. So basically got to add 4 to both sides, and that's 15. So c is 15, and then basically we got y equals negative 4/3 x plus 15 is our answer. And look, that matches what we got over here. So make sure you can use one of those methods, or if you're really good, use both.